Correct answer. In the same way, you can now vividly capture the right answer here. He says, which of the following statements about friction is not correct? The emphasis is not correct. Now, it says the force of kinetic friction is less than static friction. Now, I have to expose you once more to kinetic, static. When the body is at rest, we talk of static friction. As far as the surface is rough, there must be frictional force. At that point, the body is at rest. Friction is there. We talk of static friction. Then when the body is now in motion, then we still talk of friction, kinetic friction, which might be sliding friction or rolling friction. They are under kinetic when the body is in motion. That's why we say that friction exists when the body is at rest or when there is tendency for motion. And even when the body is in motion, we talk of kinetic friction or static friction. Now, as far as friction opposes motion, then the simple idea now will tell you that static friction is greater than kinetic friction. Because when the body is at rest, it means the opposition tending to stop it from being moved is high. That's why the body is at rest. It will have the maximum static friction that we normally say the limiting frictional force. Unlike a body that is in motion, when the body is in motion, it means that opposition, that resistance, that frictional force that opposes motion is small. And that's why the body is now moving. That's why the body can be sliding or rolling. So static friction is greater than sliding or rolling friction. Static is greater than kinetic. Even these two bodies that are maybe two bodies, one is rolling, one is sliding. The rolling one moves faster than the sliding one, meaning that opposition is more here. Frictional force is more on a body that is sliding than one that is rolling, because friction opposes motion. If you are moving faster than expected, it means the frictional force is more, is not much. Now, so in this way now, he says the force of kinetic friction is less than static friction. Is correct. But we are looking for one that is not correct. Then the force of kinetic friction between two surfaces is independent of the areas in contact. That's from the formula. Whether kinetic friction or static friction, once it is friction, is independent of the area. The area is not here in the formula. So B is not, this is kinetic friction between two surfaces, is independent. So is a true statement. And we're looking for one that is not true. So B is still true. Then C says the force of rolling friction between two surfaces is less than the force of sliding friction. We have established the fact here. So when the body rolls, then the degree of movement is more than the body that slides. So the opposition is more in a sliding body than that of a rolling body. So that one is still okay, is right. Then option D says the angle of friction is the angle between the normal reaction and the force of friction. So that statement is purely wrong. The angle of friction may be in an inclined plane. Then this is the angle of friction. This is a rough surface. And this is the horizontal. So the angle of friction is the angle between the horizontal and the rough inclined plane. So this statement is not correct. So once we are looking for the incorrect statement, I mean the one that is not correct, then we now accept D being incorrect. Now, number 3 says the coefficient of friction between two perfectly smooth surfaces. Imagine perfectly smooth means that the body is devoid of frictional forces. There is no opposition to the movement. There is no friction. The body is perfectly smooth. And once, that's why we are talking of the nature of the surface. Now, the surface is not rough. Is perfectly smooth. Then there is no frictional force. frictional force doesn't exist there on the perfectly smooth surface. And because of that, the coefficient of friction will be 0 because the frictional force is mu r. Now the frictional force is 0. So if we divide the normal reaction to get the coefficient of friction by saying 0 now over r, you still get to 0. So the coefficient of friction is 0 because there is no frictional force. It's a measure of the roughness, and there is no roughness there. Then, so in that case, the answer is C. The coefficient of friction between two perfectly smooth surfaces is 0. Number 4 says, which of these are first frictional force? A says the relative velocity. Look at the formula we established earlier. There is no velocity in the formula. There is no V here. So this statement, it doesn't affect the quantity here, relative velocity, doesn't affect frictional force. Then B says the color of the surface is independent. The color is independent of the color. What it depends is on the nature of the surface, whether the surface is rough or smooth. So that if the surface is rough, there will be friction. If the surface is perfectly smooth, there is no friction. Then C says the area of the contact of the given surface. As far as the area is not here in the formula that F equal to mu r, then it means that the frictional force does not depend on the area in the contact. Then D says the nature of the surfaces in contact. That's right. It depends on the nature. That's the nature of the roughness of the surface. So with this now and the explanation, you'll be able to answer theoretical questions both in your text, jam pass questions, and WAEC. From the analysis, you will answer them without hesitation. Then next topic, I will expose you to the calculation aspect, how you can apply the formula and get the calculations easier. Thank you.